4b.5, which means Unit 4, the second half, which is the modeling or real life application, and page 5 if you're following along in the online tutorial. So today what we're going to be doing is getting into some geometric sequencing. So we've already looked at some sequences in the past where you added or subtracted between terms to figure out what the next term was. In this case today with geometric sequencing, what we're going to be looking at is when you multiply or divide, or multiply by a fraction, which is the same thing as divide, in order to find the next term. So, geometric sequence. Remember, each number in a sequence has a special name called a term, and the position number is called n. It has a special letter associated with it. It is the letter n. So the first term, the second term, the third term, the fourth term. Now, these are the input values or the domain. Okay, so the position number is always the input value. And then the output value, if I asked you, well, what's the first term? You could easily tell me it's 3. So you have to ask the input value to determine the output value. So the first term is 3. And now 3, 9, 27, 81, all of these are the terms. And this is the term of the sequence or the value of the term. And that can be seen as f of n or a sub n. And this is considered the y value, the dependent value, and it's what determines the range. So domain and range, you still have domain and range, even with geometric sequences, okay? So the main thing that makes a sequence a geometric sequence is what we talked about before. We have to know that there is a ratio between them. So they're going to multiply or divide instead of adding or subtracting. So that means that there's a ratio, and how you find the ratio is you divide this later term by the term right in front of it, and that's going to give you the ratio. So if we take this and we take 81, nope. We take 81 divided by 27, we get 3. So let me go ahead and write 3 here in between the 27 and 81. And if I take 27 and I divide by 9, I'm going to get 27 divided by 9 is 3. And then 9 divided by 3 is 3 as well. So in this case, our ratio is 3. Okay, so you get the ratio by dividing one term by the term in front of it, and that's how you determine the ratio. And if it has a constant ratio, meaning it's the same no matter what, it doesn't change, it's going to be a geometric sequence. One thing we need to look at here is the fourth term, and the sequence is 81, right? And so we can say f of 4 is 81, or a sub 4 is 81, okay? And so when you have the explicit rule here, you say f of n is 3 to the nth power, or a sub n is 3 to the nth power. And so that's an idea of explicit rule, which is what we're going to get into on the next page after this. First, we need to look at these sequences here and make sure you understand what a geometric sequence is. So I want you to pause the video and determine for yourself if these are geometric sequences or not. All right, welcome back. So how we determine if it's a geometric sequence is we divide. 1/4 divided by 1 is 0.25. 1 divided by 4 is also 0.25. 4 divided by 16, 0.25. And just to be sure, let's do this one too. 16 divided by 64, 0.25. So this one is a geometric sequence, and it has a ratio of 1/4. Okay, that's the same thing as dividing by 4. So 64 divided by 4 is 16, divided by 4 is 4, divided by 4 is 1, divided by 4 is 1/4, divided by 4 is 1/16, and so on. So let's look at this one. 22 divided by 17 is 1.294. All right, I don't think that's going to be a geometric sequence, but let's give it a shot. 17 divided by 12 is 1.41416. So this already I can tell is not a geometric sequence because the ratios do not remain the same. They're not constant. So let's look at the next one. 16 divided by 9 is 1.7 repeating. Okay, well, that gives me hope, some repetition there. All right, 9 divided by 4 is 2.25. Oh, bummer. Darn, darn, darn. So those are not common. They're not similar. They're not the same. They're not repeating. So this is not a geometric sequence. All right, so let's try this one. Negative 40 divided by negative 20 is 2. Negative 20 divided by negative 10 is 2, and negative 10 divided by negative 5 is 2. So this is a geometric sequence, and the ratio in this case is 2. I know you got all those right. You're smart. All right, so explicit rule. Remember, an explicit rule tells us what a particular term's value is if we want to know a particular term based on its position. So if I say, what's the 9th term or the 110th term or the millionth term, I can plug that in and find that out. And so you need to pause the video and write this down. We have an explicit rule, A of n, A sub n is A sub 1 times r to the power of n minus 1. Now you also need to write down what each term is. A sub n means, well, which number term are we looking for? Okay, A sub 1 means the first term. So 1 right here tells us that it's the first term. R is the rate. Remember, we already determined how to figure out what the rate is. And N is the term position. So if we're looking for the 9th term, it's A sub 9, and then it'd be 9 minus 1. So let's look at this problem right here. We have some Japanese sword makers. They really make some pretty cool swords in the 1400s. They would take metal and repeatedly fold it over and fold it over and fold it over and fold it again and hammer it down to form some layers. This folding process increased the strength of the sword. And the table we have below tells us how many number of layers are in each sword, and it depends on the number of folds. So we're asked to write an explicit rule for the geometric sequence described by the table. Now, hopefully you followed directions and you wrote down your explicit rule in your notes. So remember, that's going to be A sub n is A sub 1 times the rate to the power of n minus 1. So let's look at this information and see if we can figure out what these letters are that we can sub in for some numbers. So A sub n, we can't figure out that yet. We're going to keep that. That's part of our problem. A sub n is A1. Okay, well, A1 means the value of the first term. So this is the position 1. That's the first term. So the first term is 2. So A1 is 2. So I'm going to put 2 in here where the A1 goes. Now the rate, we need to figure out what the rate is. We haven't figured out the rate yet. So we need to figure this out. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. So our rate is 2. So I'm going to plug 2 in for the rate as well. And then I leave my n in the equation, n minus 1. And that way, if I'm asked, well, what's the, if I fold it 110 times, how many layers will there be? Well, then you plug in 110 where this n is. I don't think that's possible. I mean, we can't even fold a piece of paper 110 times. Why would we be able to fold a piece of metal that many? But you just plug in whatever number of folds here where the n is to find the answer. So that is an explicit formula now, or explicit rule. So now we're going to look at the recursive rule. The recursive rule is, remember, it's determined based on the term before it. So the recursive rule, you not only have to have the equation written, but you have to be given a term. Usually it's the first one. A1 is the given, okay? And this rule is only for any term that's in the position 2 or greater. So when n is greater than or equal to 2. And a sub n, we know, is going to be our output value. We don't know what that is. And a sub n minus 1 means one less than what we're looking for. So if you're looking for the 7th term, this would be a sub 6, okay, times r. You know, r is the ratio. All right, so here is that same problem we had before. We need to write a recursive formula for it. So remember, our recursive formula was a sub n is a sub 1 minus n times r. And our rate was 2, right? Remember that? Our rate was 2. So in order to write this formula, we're going to write a sub n is a sub 1 minus, n minus 1. That's an n minus 1 times 2. And then we all have to also include in the formula at least one of these terms. And usually you include the first one. A1 is 2. And that is our recursive formula. All right, so now we have some practice problems here. I want you to go ahead and pause the video and see if you can figure them out on your own. Welcome back. The first term of a geometric sequence is 6. So I'm going to go ahead before I even continue reading and write a1 equals 6. And the common ratio is -8. Okay, so r equals -8. I like to go ahead and write the information. And we're looking for the 7th term. So I want to write, the easiest way for me to figure this out is to write an explicit formula. So I'm going to go ahead and write my explicit formula here. A sub n is a1 times r to the power of n minus 1. So I know that's my explicit formula. So now I need to substitute in all of this information that I determined earlier and see if I can get a math equation here. A sub n is 6 times, what is my r? -8 to the power of n minus 1. And we were asked to find the 7th term. So what that means is I'm going to take this 7, so n is going to equal 7, and I'm going to plug it in for where this n is. So what I'm going to plug into my calculator is 6 times -8 caret, and you can do it 2 ways. You can go ahead and put the 7 in where the n is and do -1. Or if you want to do that math in your head, because it's already pretty easy, you can just put a 6 in. 7 minus 1 is 6. All right, so 6 times -8. Now you need to make sure on your calculator you use the negative button. It's different than the subtraction button. So use your negative button. 6 times -8. If you use your subtraction button, you might get an error message. Caret 6, I'm going to put in. And so my answer is -1572864. When I look at the calculator, I don't write in a straight line. Sorry about that. So this is my answer, -1,572,864. Now we're asked to write an explicit rule for the geometric sequence. I know that this is going to be A1 is going to equal that. Now I need to figure out what my ratio is. Let me change colors here. A1 equals -4. So let's find out what our ratio is. 36, -36 divided by -12 is going to be 3. And let's just double check that. -12 divided by -4 is going to be 3 as well. So my ratio is going to be 3. I already have an explicit formula written up here, so I don't want to write that again. I'm just going to fill it in. A sub n is a sub 1. Well, a sub 1 was 4 times r. What is r? R is 3 to the power of n minus 1. All right. So that's all we are asked to do, write an explicit rule. So we are done. That's our final answer here. All right, moving on. Use the rule you wrote in number 2 right here to find the 12th term. So in this case, n is going to equal 12. All we got to do is plug that in and put it in our calculator. 4 times 3 to the power of 12 minus 1. So in my calculator, I'm going to do 4 times 3 caret, and I'm just going to put in 11. 4 times 3 caret 11 is 708,588. All right, so that's my final answer, 708,588. All right, now this one was a little trickier, but I hope that you were able to figure it out. So given that A2 is 12 and A4 is 192, we are asked to find A1. So let's go ahead and write some little A's here. I've got all of them written out. I'm going to create a little table. So I know A4 is 192. I don't know what A3 is, but I know A2 is 12, and I know we're looking for A1. Okay, now if I think about the two formulas that I know, the two rules that I know an explicit rule and I know a recursive rule. Well, just thinking logically about math and the fact that this is an assignment, we've already used an explicit rule, so we got to use a recursive rule. But the recursive rule actually makes more sense. So let's look at why that is. So A sub n is A sub n minus 1 times R. Well, because we're missing some things here, we're going to have to use some substitution. So let's say if we're looking for A sub 3, we don't know what A sub 3 is. A sub 3 is A sub 2 times R. Oops. We have to use something we know. Let's do A sub 4. A sub 4. We know what A sub 4 is. That's 192. 192. A sub 4. And A sub n minus 1 is A sub 3. A sub 3. Okay. Times R. And we don't know what R is. Now, we don't know what A sub 3 is, but we can figure it out. A sub 3 is, if we use that same recursive formula, it's A sub 2 times R, right? And we know what A sub 2 is. A sub 2 was 12 times R. So if we take this formula right here and plug it in, right here where A sub 3 is, then we'll be able to figure out what our R is. So let's go ahead and do that. I'm running out of room here. 192 is, I'm going to input instead of A sub 3, 12 times R, 12 times R, and then I still need to put my times R in there, times R. So I've got 192, oops, that's 9. 192 is 12 times R squared. All right, well, we can figure this out, can't we? Well, we're going to do 192 divided by 12. 192 divided by 12, and we get 16. 16 equals R squared. Well, anytime you insert a square root to undo a square, you're going to have to give a plus or minus. So this is plus or minus 4 equals R. Now, we need to determine, does this mean that we have a negative 4 or a positive 4 as our rate? Well, 12 times a negative 4 would be what? Let's see, 12 times negative 4 is negative 48, negative 48, and 12 times a positive 4 is a positive 48. Well, negative 48 times negative 4 is 192, and 48 times 48 times a positive 4 is 192 as well. So the signage does not matter, but you need to keep in mind whenever you insert a radical to undo the square, it's possible to have either a positive or a negative as your answer. And you need to look at both and see if either one is correct. In this case, our negatives, our signage just doesn't matter. So we can just say our rate equals 4. All right, so if our rate equals 4, I'm going to clear up some room here. Remember, our original question was, what is the first term? So if we know that our rate is 4, all we have to do is take 12 and divide by 4, and we will get our first term. So A1 equals 3, and that's our first term. All right, have fun doing your lesson, and I'll see you on the next one.